In the last video in this series, we're going to talk about complex numbers. We're going to do a very brief discussion of complex numbers. If you have to go on to college algebra after this, you will study these in more detail. So the imaginary unit is denoted with a lowercase I, and it is defined as I equals the square root of -1. So the square root of a negative number does not exist in the real numbers. So now we've introduced a new type of number, a complex number that can deal with this imaginary unit there, which is the square root of a negative number, square root of -1. And that's where I squared, it would equal -1. So if this I equals the square root of -1, then I squared equals -1. So if b is any positive real number, then the square root of -b is equal to b times the imaginary unit, or the imaginary unit times b. It doesn't matter what order we do that in, but we generally, things that are outside the square root, outside the radical, we generally put them in front. So this would be the preferred format there, but they're both correct. And let's see why that is. So we can rewrite the square root of -b as the square root of b times -1. And then we can use our product rule for radicals to split that up into the square root of b times the square root of -1. And we've just said the square root of -1 is the imaginary unit, so we have the square root of b times I, or again, we can write that as I times the square root of b. Again, this is generally the preferred format, and it's simply so it doesn't look like something that's outside the radical is still inside the radical, and if we write it in the back, it's a little easy to get confused. So let's look at a couple of examples. So I could rewrite the square root of -81 as the square root of 81 times the square root of -1. And then the square root of 81, well, hopefully we know 9 times 9 is 81. So the square root of 81 is just 9. And then the square root of -1, that's our imaginary unit. So the square root of -81 is equal to 9 times I, or shorthand, we would just write that as 9I, and the multiplication would be understood. So why don't you pause the video there and see if you can work out the square root of -5. All right, I'm going to assume we've done that if so desired. So we have the square root of 5 times the square root of -1 if we split that up. 5 is not a perfect square, and it's already a prime number, so we can't break it down any further. So square root of 5 would just come down, and then times I, the imaginary unit. And then we can bring that I in front, and we've got I times the square root of 5. So all that we could do there is factor out the imaginary unit away from the square root of 5. So again, you may want to pause the video and see if you can go through the last two examples. All right, I'm going to assume we've done that if so desired. So square root of -50, we've got the square root of 50 times the square root of -1. So that's equal to the square root of 50 times the imaginary unit. Now 50 is not a perfect square there, but let's see if it'll simplify. It's not a prime number, so let's make a factor tree for 50. 50 is, we could do 5 times 10. 5 is prime, so we bring it down. 10 is 2 times 5. So we can rewrite there the square root of 50 as the square root of 2 times 5 times 5, and then outside the radical we have times the imaginary unit. And we do have a perfect square in there. 5 times 5 is in there. So that is 25. So let's factor away the perfect square. So we got the square root of 25 times our leftover, which is the square root of 2, and then times the imaginary unit. Well, the square root of 25 is just 5. We can bring that imaginary unit in front with the 5, and then we generally leave the square root factor, the part that's still left over inside the square root, in the back. So we end up with 5 times I times the square root of 2. Last example there, we have square root of negative 9. Well, we can factor that away into the square root of 9 times the square root of negative 1. And then 9's a perfect square. 3 times 3 is 9. So the square root of 9 is 3. So we have 3 times the imaginary unit I. So 3 times I. We can just write that as 3I. So a little bit about the imaginary unit. You may encounter that periodically when you are solving quadratic equations. So it's good form to realize that if you have a negative number beneath the square root, your solution is going to involve the imaginary unit. All right, so that is the end of this lecture series for simplifying square roots.